Welcome to this new lesson on Linux cybersecurity. This video has been originally done for the cybersecurity school in Vannes in Brittany in France, and I had to record them due to some professional traveling, and so I have decided to share them at the same time. This is actually the lesson 2. In the lesson 1 we really focused on what was around the boot, and insist always on that part, because a lot of things which can happen before the boot of Linux or before the user space boot, so everything dealing in the BIOS and the UEFI BIOS, in the plugin of the bootloader secondary stage like grep, or even through systemd and task launched by the display login manager are pretty silent, and some of them even can be launched under Linux through hypervisor mode, and then can be completely invisible. So we assume that that has been understood, and today we are going to focus on a Linux which is working quietly, user space is active, and we consider that what has happened before did happen correctly. If you have any doubt, just go back to the first lesson. So, let's go in full scale. So, today we're going to talk about capability to monitor what is going on, and especially what is dealing with management of the quota of the hard drive, and furthermore what is dealing with the Cgroup, which in one way Cgroup are just an extension of a concept of quota to plenty of different subsystems from Linux, significantly more powerful. Unfortunately, quite often ignored. And we will finish on seccomp. Seccomp is not for everyone, but it's quite interesting to know that it does exist and what it can and cannot do. So, we will focus on resource access control. A short track on ACL, quota, Cgroup, seccomp. The goal here is really to find what are the methods which are given by Linux to limit access to resources. Because this is a very valid form of protections. It can slow down an attacker. It can avoid for a malicious code to take control of your entire machine, which give you a chance and an opportunity to actually take control back over him. So ACL, we talked a little bit about ACL. I just want to make this remembering as a small reminder to the people. ACL are based on the default DAC, discretionary access control. And as discretionary means in English, it means that it's kind of optional, which means that yes, it's mandatorily there on most of file system, FAT being the notable exception in Linux world. It's definitely better than nothing, but unfortunately the user can change the setting, and that means that malware that would be running as a user, for example, some malicious code hidden in an email or running under the browser, would actually run with the same privilege as the user, and that means it can change the DAC and extend access of file directories to other group and other users, which is not always what we want to do, even can hide it from the user. We have the extended ACL. We didn't talk much about it in the first lesson, we just gave the name. We will not talk in detail, but they can be quite practical, very simple tool. Have a look at the manual for ACL. It's quite useful to ban some pretty dangerous utilities to access some things. So, for example, you can decide that wget cannot be used by the user running your web server, quite often Apache or HTTPD, because you know that your web server doesn't need to get wget curl as well, And in that case, if someone succeeds to kill your web servers and go in in a shell mode behind, or just use some weaknesses to run some uncontrolled command or undesirable command, those will be forbidden. So it is very simple. It's practical. It's still discretionary. But if you apply ACL to typically utilities, which traditionally are owned by root, as a user, well, a normal user would not have capability to change this restriction. So it's actually a pretty simple tool, not used that often, but which is very efficient. Unfortunately, all forms of ACL are pretty useless when it comes to network drive, and especially when it comes to share information. There are some tricks in the ACL to do it, but let's be honest, it doesn't really work that well. The disk quota, in one way, I kindly, as a general principle, is a bit of an extension of the ACL. What it does is that this time we're not going to avoid that the user use a file or write on it or even read the directory content, but we're going to restrict the space that the user is allowed to use on a given disk. Actually, we can limit the space, so the numbers of blocks, as well as the numbers of files, because typically the inode, the number of inodes can be limited as well. It works by mount point, so it's one of the concept of the quota. It works on mount point. It has capability to put limitation on physical partition, but also on logical partition created by LVM. And either on subvolumes, if you use BTRFS. You can even do concept of quota group and BTRFS. This said, I'm not the best fan of BTRFS in my past experience. It's a file system which can do a lot, sometimes too much, and which also well known to be capable to crash a system after 1 or 2 years of operation. And so it's really a trade-off that you have to think between the functionality provided by the file system, BTRFS, against the extension of reliability. If you have to make a very reliable system, I would still, in 2017, prefer an LVM system to a BTRFS for whatever I do. A RAID, encrypted partitions, yes, a question of reliability here can be very important. But both solutions can apply. It really depends how you use. BTRFS features are great. So these quota are based on UID or GUID, not UEID, but group ID. And it's usable on any file system. That means that more or less you can use it for whatever you want, including a FAT. It's not really depending on the file system. It also works on network file system in that way, so which can be very, very handy. Now the capability is created using two tools. One is called usrquota and the other one grpquota, which pretty self-explanatory. Tell what you want to do, and because it's amount options, you're going to find the quota traditionally added in the FS tab, where you're going to put it as an options of the mount. And then you're going to define a configuration by a special editor. You could do it by hand, it's not advisable. There is a tool called Edit Quota, which does it for you, and will do it right. And you can set hard and soft limit. Because quota, we'll see later, are quite an old tool, and in one way Cgroup is doing so much better that it's not used that often. So you have to install a package most of the time. Most of this tool called quota. As I've said, BTRFS has its own tool set, and you have to look at the BTRFS quota enable mode to see what features are available. This be done, you're going to be able to set up some hard and some soft limit. So here, if we look at the slide, we see that we have for a given logical volume 2 a limit which has been set up to 440,000 block depending on your file system can vary quite often between 1 and 4K is the most common value, and we have a soft limit which is set up to 50,000 to 500,000, so a bit higher, and we have a hard limit at 550. So, and the numbers of inode as well as the input limit there. What it does allow us to do is that it will allow us to get limits which will be potentially overwhelmed during a given grace. So that's what we have. We have grace system. So then we're going to establish a quota for a given username, and that's done, as I've said, with the command edit quota. And that's the second block of information that we see as an example. And we put the limit in that case with no grace. It's a choice. So if you define a grace, the grace time will have the capability to be configured in a few seconds to a few days or a few weeks, even months. My advice is don't make it too long, otherwise user will consider it as taken. What a lot of people don't realize is by default in Linux you have a quota which is to 90% of the use of any partition for non-root user. So if you are a regular user, you will be limited to 90% of use of the / at least configuration. So that's designed to avoid to crash the system. This it's still very possible to crash it by blocking it. But if you have the quota, it will be protected on that point. So if someone just overwhelms a file system, for example, with a log which is going too big, it's a pretty common problem, you can actually stop that to happen because the process will actually be refused to write and most of the time will simply crash. Now, obviously, if you establish a quota, you will have to do some monitoring and potentially some reporting to the users who are actually controlled by those quota. And you have numbers of tools. You have the report quota, which can be used. You have a capability to do permanent monitoring with quota check or warn quota, which are tools which are running through cron tab. So the cron tab is a solution in Linux to describe or to register tasks which have to be executed on a regular basis. Quite often you have a standard entry for daily, weekly and monthly, but you can even give by a manual entry using cron tab -e, which will call the editor and edit for any user who has a cron tab capability to create a task that will be run once in a while. The system is quite flexible. Just make a man of quota and you will have all the detail. So with that you have the capability to enforce a maximum size of your files using in a partition for a given user or a given group, as well as you have the capability to report it automatically and to send mail to the user if they are getting close to their quota. Pretty simple and very practical method. Now, from a security point of view, the interesting point is that if you establish quota as a general rule, especially for anything which is creating a log file or has capability to receive file, it will guarantee that in case of an attack, the attacked application will not have the capability to fill entirely the partition until the system crash. The application will be crashed by the system as soon as it will reach its hard quota. So it's a very basic but extremely efficient method to avoid a system to be overwhelmed by an uncontrollable side effect of malware creating files and files and files. Now, what I was saying at the beginning is that the quota, well, very handy, has been pretty well overwhelmed by Cgroup. This said, Cgroup is very underused. It's something which is a bit shocking, and I cannot really understand why. It's pretty simple to use. It's very efficient. It's been there for now a bit of time. Likely is mostly ignorant. So what Cgroup is Cgroup is really like getting into the club. You have a number of tests, and there are things you are allowed to do, and if you try to do more than what you've been allowed to do, you will be limited. Now, one very specific point of the Cgroup to remember is that for numbers of the limit, you will have the capability to use entirely the resource until someone else is trying to use it. And that's a very important concept to understand in Cgroup. If you give capability for example, a task to use a maximum of 20% of CPU, it means that it will have that limit with the CPU being starved. But if the CPU is not doing nothing, it can still have 100%. So it is a very nice concept, because you can actually give a full access to resources which are dynamic, like for example the I/O on the block device, for example the hard drive, or the CPUs, or the RAM, and say, on the network you can use it as much as you want, but if the system is starving, then you will be restricted to a given amount. So it's a very important point to remember when you set up your limit. A lot of people want to set up limit at 90% for CPU, thinking, oh yeah, because my task is very important, but I don't want it to completely starve my system. Would it get out of control? For example, a database. And they put 90%. That's wrong. You should really more give it 30%. You should give it what it does normally. Potentially a bit of a hit, but not much. And if your database normal usage is taking 20%, then controlling it by Cgroup to 30% is likely a very good idea. Now, it will still have 100% of the CPU to do very fast tasks whenever needed, if the CPU is not overwhelmed, which happened with database. But if a malware starts to completely take control of your system, you will never get to the maximum. And that's an important point. Obviously, from a security point of view, it's pretty obvious that this type of control, which are offered by Cgroup, are going to guarantee that a malware taking control of an application and so executing within a given Cgroup set will have restrictions, which means that you will be able to go back into your system, understand what is happening, and potentially kill the application and the malware that needs to be killed, correct your problem, and restart your system clean. Which means that you can do an analysis while the overwhelming of resources and the starving of resource is happening. If you don't have Cgroup, what quite often happens is that the system is starved to death, and the only thing you can do is to actually stop it. And then you have to do a post-mortem analysis, which is significantly more difficult to do. So in that case, if you have been a bit smart, you're going to be able to do it while the system is running. So let's look at how we organize a Cgroup facility. The Cgroup is actually organized following a concept of a tree. But the particularity is that the tree is created by the user who wants to establish the control. So you're going to create branches by different subsystems. You're going to allocate to each of these branches some restriction. We'll see later how. And once you have defined your entire system, your entire tree, you're going to allocate tasks to belong to one leaf. And then the task will inherit all the restrictions which have been done. Now, Cgroup only allow directory. You're not capable to, or not allowed, to have a branch belonging to two trees at the same time. That's one restriction which is put on Cgroup. So each time you're going to put a restriction on a high level, it will automatically be cascaded down to all the other levels. The other interesting point is that you will have the capability to make some process child by a spawn, or you're going to create as well thread, and everything you're going to create from a given branch will have the same restriction than the father. So on that point there is no way to escape the restriction enter on Cgroup. Even if malware succeed to break an application and succeed to spawn another process from there, that new process will have the same restriction than the first one. Let's take an example. You have a web server and you have put Cgroup restriction to that web server that it will not be able to get more than 50% of the CPU and 50% of the network bandwidth. If the web server is taken over by a malware because you had a weakness in a CSS or in a PHP code, the malware will have exactly the same restriction. So that's a very interesting thing. Now, the second interesting point with Cgroup is once a tree is created, it actually creates a tree which is visible on the pseudo file system, so it's very easy to understand what is happening. And you can add tasks very simply by making an echo into the pseudo file system with the PID of the task, and immediately the task will inherit of the limitation imposed by that Cgroup. So that means that you can actually activate control and limitation on a task independently of that task. So that one very good point. And after the fact, which means that if you have, for example, a Cgroup which is waiting, which is going to be called, for example, low priority, if something gets out of control and you have one task which is getting crazy, you can put it in this protected group by just a simple echo and have the capabilities then to check what's happening on that task, because more or less it will not be able to starve the system anymore. Now, depending of Linux configuration, you may have different options which have been compiled in your kernel, and not all the possible subsystems manageable by Cgroup are always configured. Now, in most distros, the common one will be there, so you don't have any doubt. But nevertheless, you want to check what is in your subsystem. In a similar manner, within each subsystem, you have a number of valid options which are actually there to allow control, and those can be different. And so that's an important point to remember. Now, first thing you will have to do is that you will have to create a Cgroup. So in that case, we created a Cgroup, and we allocated directly the CPU set, and we gave a name which was our group 1 web server. And then we can, once we have created this name, we can add parameter to this functionality. In that case, for example, we have restricted tasks that will belong to the group 1 web to the use of the CPU 0, 6, 8, 10, 12, and 14. All the other one will just not be accessible. We can also add some new features. In that case, we are adding a CPU set mem, which is an option that we can just push on the system. So we see that it's very easy to actually play with the feature of the group. And once we have that group, we just have to put a task on it, and it will automatically activate the task. Now let's have a little bit of a look how deep we can go. I just took an example of the block I/O device, and we can see that the numbers of features which are available is just amazing. In one way, it's a bit sometimes too much. You can decide, what is a throttling that we all understand, obviously. But we can also define the numbers of block and what service time we're going to allow, and it's numbers of features. Some of them sometimes you wonder if they're not even obscure, but definitely we all understand that controlling the I/O and having the capability to restrict the numbers of bits per second that we are going to give to a device is a pretty obvious way to actually control such a system. If we look at the memory, we'll find that we have roughly equivalent systems. So we're going to be able to say how quickly we're allowed to access to the memory, how much we can access to that memory, and so on. So it is a very interesting point. Now, on Cgroup, roughly we have done a tour of what is available. Now, I don't have the pretension that we have seen everything, and I will just quit a little bit that to show you some other resources, because I believe that it's just worth to do it. So we're going to try to load my browser, which could take a bit of time because my system. Why a browser will always crash when we don't want it. Sorry for that. Yes, so we talk about quota. We'll not come back. There is a link which given that. I wanted to go on the subsystem. So the subsystem and this resource is given in the slide deck. The first one we talk is about block I/O. So which more or less everything which is a block device that you can dream to control about, which is there. So we talk about the a limit of read operations and the limits of bit per second you want to allow, the limit you want to put on a write. It's a quite classical system, I would say. So now the other one we talked about was CPU. CPU is let's give it time a bit. Yes, so we talk about the tunable parameter of the CPU. So numbers of microseconds, for example, that a group can access, quota and quota of statistic. Do we want to throttle it? The number of CPU share. To be honest, most of the time, the basic percentage of use will be will be doing, which is probably CPU share. It's a quite traditional way of doing it. The next one on CPU is actually the report of CPU, that's CPU Act, which allow you to follow the usage of CPU and to report it, which is more monitoring features, to be very honest, than a resource. CPU set allows you, that's the one I had in my example, to decide what are the CPU which are going to be used and which one you are not going to allow. If you're going to allow to let them migrate, and if you have some capability to overcome this limit for a bit of time, and all the detail you won't dream of. As you can see, we don't have, obviously, in the course a detailed time to look at all the detail, but the link is there in the presentation, and it's up to you to look at all the options. Now, from a security point of view, mostly what you want to do is to guarantee that you will have capability to get into the system with malicious code, take control of it. Devices, it's same. It's what are you allowed to use. The good thing with device is that allowed to block character as well as device character. So your serial port, for example, you're going to be able to get control of them in that way, which is something which is also allowed by the other way. You have other methods to do it, but this is a very simple way and a very dynamic way to do it. The freezer is a more obscure option in one way. It's actually to allow to get tasks to be suspended or not, which from a security point of view is unlikely to be used. Memory is an obvious one, a bit like CPU and the block I/O and the device control. We all understand that starving a system by the CPU, by the memory, by the network is a very common point. So you're going to actually allow to make it, and then you can define, what you want to do and which option you want to have. And once again, it's a pretty long set of options that you need to look at quite actively. But it is definitely very interesting because it will definitely put your system under control in a very efficient way. It goes far further than memory usage. That's an obvious one, but you can decide if the swap can be used, if the TempFS can be used, and how much it can be used, and so on. So even if you have a big TempFS, for example, because your system needs it, but some applications are not supposed to get access to it, you can actually restrict access to TempFS by given application. So it is, once again, a very, very flexible system. You have soft limit and hard limit. So it is really, a very powerful command with a lot of sub options, which quite logical because memory is potentially the best way to starve a system. You just have to run it over, and then you can quite easily make a denial attack by that method. The network then is the next step, which actually allow to, so the class allow to create class of traffic, and then from this class of traffic you're going to be able to define what limit you want to do, and then you're going to have your network priority, and your network priority is, I would say, more obviously, what you're allowed to do and how much you're allowed to use the network. And then we have the last one, which is related to namespace, which fundamentally provide a way to group processes into separate namespaces. So that's one way to force isolation between processes, and that's a way to actually move a process to a space. But this is a bit more complex than just a traditional grouping used by Cgroup. So if we summarize on the Cgroup, the feature you really want to investigate are related to the control of block devices, because you can do throttling and you can do maximum use, and it's a great complement of the quota that we've seen before. The device is mostly to stop access to device or to allow access. It's quite interesting when you want to deactivate, for example, some devices like, for example, the USB. You don't want a task to be able to access to USB because it should not. Why to let it do it? You know, your web server is not supposed to read a USB stick. Okay, so it's a very simple way. Just remove it from there, and you will never access to it. And the RAM, obviously, which is the most complex one. It has plenty of options and sub-options. But you know, putting restriction on a RAM is something that will guarantee that your system has a chance to survive its attack. It will not be really possible to start it. So these are three we want. The networking can be used as well, but networking, we'll see in the coming lesson that we also have the IP table or the NF table, the replacement, which can also do it. So in one way, it has a quite serious overlap, and we tend to treat quite often the feature related to firewall and throttling together. But that's not an obligation. We have seen that we can create classes of traffic, and these classes of traffic can be very handy there when it comes to do firewalling and throttling of traffic. So there is a use of it, but it's a bit more advanced. I gave you another resource which show an example, and this is an example of a task where we have guaranteed access to a certain amount of megabyte per second, and what we can see is that even if there is another task which is going to try to use everything, that other task is actually limited in such a way that it cannot take 100%, the maximum. So the red task keeps its quota available. So that's an example of typical usage. So red task, for example, could be your SSH access to go in and your monitoring device and your task, you know, whichever monitoring system you use. And the blue one could be your web access or your database, which has been attacked by a malicious user, which is trying to nick everything from the data content you have. What we can see that here, the red task, your SSH server, would still have the capability to go under control and to know what it does and be able to work, you know, because it has access to CPU, a little bit of drive and a little bit of network, enough to be able to do a command, understand what's going on, and decide to kill what you want to kill if you would like to do so. And finally, I found that training as well that I gave as a link, which is quite nicely. It's written for administrator, to be honest, but when it comes to protection of resources, that course is actually well done. It explains how to install now the latest version of CentOS. Don't use yum, so you will have to change the command for install packages, but it still remains extremely relevant. And the methodology and the tests which are proposed is something that likely you want to play with. It's quite a nice system. So with this, we have finished the Cgroup, and I'm going to come back to my presentation. It's not what I wanted to do. That's going to take forever. Let's do it in another way. As I'm recording my desktop, my system is overwhelmed and my CPU is entirely busy recording what I'm showing you. So seccomp is a bit of a special thing. It's also called sometimes seccomp BF because the stuff is coming from the packet filter from FreeBSD, which are used in NetFilter. So we use probably the NetFilter package to pass the command. What seccomp does is that it allows to do filter to the Linux kernel system code. You have the capability to establish pretty sophisticated filter with NetFilter, and you will say that a process is allowed to call that API, not allowed to call that API, or allowed to call that API with that given parameter. It is very commonly used by browsers. Browsers use seccomp to restrict what the tabs that you open are allowed to do. And for that, it's absolutely great. What you have to know about seccomp is that on the paper it looks extremely powerful. You say, oh yes, with that I can restrict, what really I want. But in practicality, it's extremely difficult to use it. The first side, it has a sizable impact on performance. So as soon as your rule starts to be complex, your CPU usage just for filtering your code to the API can easily reach 5, 10, 15%, which is far from being negligible. But more than that, the child don't inherit of restrictions. And this is very, very tricky. So you really have to make sure when you create a child, you give the restriction as well. Now, in a browser world, that is quite easy because you don't execute binary code. The browser is going to load fundamentally JavaScript code. And that JavaScript is interpreted by the machine inside the browser. So the virtual machine inside the browser has a restriction, and the code has been written by the browser manufacturer. And so the restrictions are pretty well ensured. So it is probably limited to well-behaving application, Firefox and Chrome, for example. But if you have an application which is potentially at risk of being hacked, but not using spawn and thread like we do a web server, it is still a powerful tool, because if you have control of your code and you have access to the source code, because here you need to recompile the application to apply the filter, to enable them at least, it is very nice. It's definitely very, very powerful. But as I've said, it's, in most of use cases, it's actually not usable. So don't really believe it's a magic tool. So with this, we arrive at the end of this lesson 2, which I hope has been a pretty simple one. What we've seen is that the quota, they are basic, but they're available on most systems, including a lot of embedded systems. It's outdated by Cgroup for sure, but nevertheless it can do things which are pretty handy, and especially to warn the user who are getting over the size that they should use. So it's not bad for that. Making such report with Cgroup would not be that easy. Cgroup is definitely very powerful and simple to use, but it is underused, let's be very honest. The ease of use has even increased because now systemd has a capability to activate Cgroup when it launches the task, so you can do it dynamically. So it is really very, very easy to use it. It's definitely worth to spend a few minutes to master it. You have to do a few workshops, you have to check a few things, but it is simple to use. And if you spend 10 to 15 minutes to do a few tests, you will have understood how it works, and and then you will start to use it in an easy way, and it will become systematic. Personally, I would advise when you start services to systematically enable some cgroupnet. To be honest, numbers of the new distributions of Linux are doing it. So when you actually load services, they put restriction on them by default, mostly to keep capability to do an SSH, and on the system would malicious code take control of a few applications and try to starve resources to death, either network, CPU, RAM, or hard drive. Seccomp, powerful but very limited. And if you don't have the source code of the application, you're not going to use it. So, now, like after every lesson, you have to do your homework. I cannot give you everything in a lesson. More or less, the only thing I can do is to make a list of what exists. You have to do some workshop to understand. So, what I propose is that look at the quota. Create two users, for example, John and Peter. Create a shared directory. So you will have a group that they have in common, and you can use the extended ACL as well instead of using a common group. It's a good way to look at an extended ACL, so you will be able to give access to a given directory to both of them. And now enforce a quota for Peter. And try to fill the disk. And look what's going on, and how it works. The easy way to fill a disk is to make a cat of /def that's 0, that will create as many 0 as the system can do, and redirect that to a file, and you're going to see what's going on. Then you can look at the reporting features and look at a little bit how it's working. We'll see. It's pretty simple, and if you take the web page that I have listed in the quota slide, you will see take you by the hand, and likely in 15 minutes you will be done. Cgroup will require you a little bit more work. So what I propose is that get on distribution, activate Cgroup if it's not done. Create two Cgroups. One that will be the low and one will be the high. And put serious restriction on RAM, CPU, and disk I/O for low. Put restriction, but not very strict. So, like 10% for one and 90% for lot, and call it high. And then you can starve your system by the same system that we've seen before. So, starving the disk is pretty easy. You do a cat of /def/0. Starving the CPU is as easy. You do a while one, and you let your bash running like crazy. It will eat one CPU, and then you can start on another one. And if you have multiple pseudo terminal, you're going to starve the CPU one by one in your system, and then you will see what happens and how you can still be capable to do an SSH, and what can be done. So really overload your system and look what's happening. If you have created a low and a high, like I advise you, you will notice that even if you starve your system through the low group, nothing is going to happen. You will not even notice it. But obviously, if you starve through the high, you will notice it. But if you have defined your system well, you should still be able to do an SSH and kill it. Which is really what you want to do. And once you will have done that, I believe you will be armed with the generic level of understanding of the capability to limit and control resource access into the basic of Linux. And with that, I tell you bye, and see you for the next lesson. Have a nice day. Bye-bye.